Good morning, student. In last lecture, we have discussed about the nodal analysis and the concept of supernode analysis. And in this lecture, we will discuss about the concept of dependent source, type of dependent source, and how can we solve the problem of a circuit which have the independent and dependent source. So first we discuss the problem which we have given in the last lecture. So see, the first problem is find the value of BA, BB and BC, and BAB, BBC and BCA is given into the circuit. So first question is it possible to find the potential of a terminal BA as BB or BC? We cannot define the potential of a point without a reference point. Whenever we have measured the potential, we always consider some as the reference point. Okay, so first we talk about BAB. BAB is BA minus BB. That is the, in this case, because A and B have only a battery of 10 volt and A is connected to the positive terminal. So voltage BAB is BA minus BB equal to the 10 volt. And same BBC, BBC is BB minus BC because B is connected to the positive terminal. So BBC is equal to the 20 volt. And what is the value of BCA? BCA is BC minus BA. And in between A and C terminal, 10 volt battery and 20 volt battery are connected into the series. So BAC is 30 volt, but C is connected to the negative. So BCA is equal to the minus 30 volt. Okay. So if we want to measure the BA, BB or BC, first we have to define the reference point. If we take suppose this C as the ground, okay, then C ground means the potential of C is 0, then BB minus BC is 20 volts. So if C is at 0 potential, then potential of this terminal is 20 volt. And BAC is BA minus BC and this is 30 volt, then potential of this terminal is 30 volt. Okay, it is not necessary that you assume the potential of this terminal is 0. This is a reference. Why we have choose the 0? To reduce the number of variable. If we will take the potential of this terminal as 5 volt, then what is the value of BB? Because BB minus BC is 20, so in this case, the potential of this terminal become 25 and BA minus BB is 10, so this potential become 35. So without a reference point or without the reference voltage, you cannot say about the potential of a terminal. So value of BAB, BBC and BC are clear and BA and BB and BC depends upon the reference point. Okay. Now, in second question, find the value of current I as shown in figure. Okay. So see, here 5 ohm resistance is parallel to the 5 volt supply. So the voltage across this terminal is plus and minus because plus is connected to the plus and minus is connected to the minus. So current in this direction, current is flow from positive terminal to negative terminal. Potential is 5 volt divided by 5 ohm resistance. So current in this branch is 1 ampere. And this is my 10 volt. So potential is across this 2 ohm resistance is 10 volt. So current in this is 5 ampere. So if we apply the KCL at this node, okay, so this is all are the outgoing current. So that is I plus 1 plus 5 equal to 0. So current in this branches is minus 6 ampere. So next problem is find the value of B0 as shown in this figure, B0. Okay, a problem can be solved by the nodal mesh or any other method. So whenever you you have a problem, just please wait or see the problem before applying any rule. Okay, so easiest method, try to assume the current in all the branch. Okay, this problem can be solved by the nodal or mesh or any other method. So see how we are solving this problem. So we have to find the voltage V0, and this 2 ohm is the having the voltage V0. So current in this branch become equal to the V0 by 2. So current in this branch is 2 milliampere, and that is V0 by 2. So this current is the sum of 2 milliampere current and V0 by 2. So this current is 2 plus V0 by 2. Current in this 2 kilo ohm is 4 milliampere current is here, 2 milliampere current is here. So total current in this branch is 6 milliampere. We have the information about this current, this 1 milliampere current, uh, and this 2 kilo ohm resistance current. So current in this branch is equal to the 2 plus V0 by 2, because that is an outgoing, minus 6 minus 1 milliampere. So current in this branch is V0 by 2 minus 5. And here if we apply the KCL, because we have the information about this current, so we can calculate the current in this 1 kilo ohm using the KCL. So now we have the information about the all resistance current. So our target is to find the value of V0. We have no extra variable. We have the branch current in the parameter of V0 factor. Okay. Now always remember, we cannot apply the KVL in this loop, in this loop, in this, and in this loop. Why? Why we cannot apply this? Because these branch or all loop has a current source, or we cannot apply the KVL in that loop in which current source is given, because for the KVL, we require two things. One is current and second is the resistance. So we does not have information about the resistance of current source. So always apply the KVL in that loop which does not has any current source. Okay. Now we are applying the KVL in this outer loop. And how can you apply the KVL? So if you are moving in the direction of current, okay, then take the positive voltage, or if you are moving in the opposite direction of current, take the negative voltage. Okay, you can reverse this process. Okay, if you are moving in the positive direction, you can take the negative sign of the voltage, and in opposite direction you can take the positive sign. So now we are applying the KVL from starting from this point. So current in this branch is V0 by 2 minus 5 multiplied with 1. Current in this branch is 2 plus V0 by 2 into 1 plus V0. And in this branch we are moving opposite to the current. So this is minus of 1 minus V0 by 2. And when we solve this, this is equal to V0 equal to 8 by 5. Okay. Okay, by mistake we have repeat this problem as the we forgot or something is wrong. Okay, we will discuss it to the next lecture. Now we are moving on the nodal analysis. So first point, what is concept of dependent source? What is independent quantity and what is dependent quantity? First we have to know about what is independent and what is dependent. Okay, suppose you are studying in a class. You see there is a number of students who always depends upon their study on the other student. So in a class, there are the two type of students always. One is dependent student, second is the independent, and second is the dependent student. But what they are not dependent in each case. We are talking in the case of study. Okay, in the case of study, they are depending. So context is always important. Suppose we are talking about a student and their father. So student expenditure depends upon their father income. Okay, so student are depends upon their father for their expenditure. So father is independent in the context of financial condition, while student are the dependent. Okay. So when we are talking about the independent dependent quantity, it's mean for a particular condition or particular type of variable, I am depending upon another parameter. So here we are talking about the dependent source. It's mean the voltage or current of a source depends upon another parameter of the circuit. So what is dependent source? Dependent source, we are talking about the dependent voltage source and current source, and its voltage and current depends upon another parameter of the circuit. First, we have seen here, these two are the independent DC voltage source symbol, and that is the independent DC current source symbol. And this is my independent AC volt symbol, and here we have represented a arrow. So this is independent AC current symbol, and dependent source is always represented into a diamond type shape, and if it has the arrow, it's mean that is a current source, and if there is a plus minus sign, it's mean it is a voltage source. So this is my dependent voltage source, and this is my dependent current source. Okay. Now next is concept behind the dependent source. What is how the dependent sources work? Okay. So see here, we have shown a resistance R with a current and Y, and this is first is dependent voltage source, and this is my dependent current source. If the voltage of this source is depends upon the voltage of this resistance, suppose I have right here, I suppose the voltage of this source is beta V. What is the significance? Whenever there is the voltage V, then this source is always has the voltage of beta V. Okay, so the voltage of this source depends upon the voltage of this source. So this is a voltage dependent voltage source. Okay, so suppose if we write here as the suppose alpha I, suppose the current of this source is alpha I, symbol is alpha I. So what is the sense of this? Whenever the current is in this resistance is I, there is the voltage is alpha I, not the current. We are talking about the voltage. So if I is 2 ampere, then the voltage of this source is alpha volt, because we have considering this alpha I. Now see here in the case of current, suppose I am writing here as suppose 2V. So this is a dependent current source, but magnitude depending upon the voltage. So if the value of this voltage V is 1 volt, so the current in this source is 2 ampere, because current in this source is double of the voltage of this resistor. So that is a voltage dependent current source. If you write suppose here as suppose 3I, so the current of this source is depending upon the current of this resistance. So that is in this case is current dependent current source. So see symbol. Symbol means if you find the plus minus sign, it means this is a dependent voltage source, or whenever you find the arrow in a diamond, it's mean dependent current source. Okay, and the magnitude dependent quantity. Okay, alpha I type or beta V type, any quantity, and the magnitude tell about the dependent quantity. It is depending upon the voltage or it is depending upon the current. Okay. Now see type of dependent source. So as we have discussed, there are the 4 sources. This is a voltage, and depending upon the voltage, so this is my voltage dependent voltage source, and that is a dependent current source depending upon the current. So this is a current dependent current source. This is a dependent current source depending upon the voltage. So this is my voltage dependent current source. This is a dependent voltage source depending upon the current. So this is a current dependent voltage source. This is a current dependent voltage source. Okay. So one point is always important when you consider a problem or a circuit having the independent dependent source. So all rule that is the nodal mesh or any theorem, is same in case of dependent case as we apply in the case of the independent source. So whenever you find the dependent source, just treat the problem you are treating as the independent source. Okay, next we are discussing one problem based on the dependent source. So see, here we have shown a problem, okay, having the independent source, and question is saying find the value of I1 and V1. How we are calculating the value of I1 and V1. So see, first point is, suppose we are solving this problem using the nodal analysis. So the circuit, this is node? No, because current is same. So no need to consider this as the node. So current is dividing here. So this is my first node, suppose A node. Current is dividing here. So this is my second node, node B. Okay, that is node C, because current is dividing here, and this is node D. So total node is A, B, C and D. Now that is the minimum number of node to solve this problem. So assume one node potential as the ground, because we have to reduce the number of equations. Suppose we are assuming node D is ground. So only three variable or three equation are A, B and C. But see, D and C node has only the potential battery or making a super node. So VC minus VD equal to minus 5 volt. So potential of battery potential terminal of BC is minus 5 volt. So we have information of the potential of D as 0 and BC is minus 5. So now unknown variable in my question is A, B and B1, because we have one dependent source, voltage source, and depending upon the B1. So one unknown variable is B1. And second, circuit has dependent current source and depending upon the current. So fourth variable is I1. So my circuit total unknown variable are VA, VB, I1 and V1. So to solve this problem, we have required total number of 4 equations. Okay. So now we are applying the KCL at node A. Okay. So it has total 3 branch. So it is the sum of these 3 current. So current in this branch, first, this is potential difference of VA. Node D potential is 0, so no need to show the 0. So this is VA, and moving in this direction, we are getting the positive sign. So this is VA minus 6 divided by resistance 2 plus 4. Okay. See, there are given the voltage V1. This equation can also represent as VA minus V1. If you are considering this voltage, VA minus V1 minus 6 upon 4. Okay, if you are considering this as the voltage, never consider this resistance. So this equation, because this is not the, that is the voltage represent across the 2 ohm resistance. This is not the voltage source. So if you are considering this voltage, never show the resistance. So equation of current in this branch is represented as VA minus 6 upon 4 plus 2 as, or VA minus V1 minus 6 upon 4. So this is very important how we are showing the current branch. So this is my first current. So in this branch, the current is given. So no need to take other variable. So this current become the branch of this current. So this is outgoing. So taking with positive sign plus 3. And current in this branch is, this is BA minus BB, subtract the node potential. We are getting the positive sign. So this is minus 3V1 divided by resistance 4 plus 2 equal to 0. So this is the KCL at node A. Now we are applying the KCL at node B. So this also have 3 branch. So this is the algebraic sum of 3 current. So current in this branch is BB minus BA. subtract the node potential, and we are getting the negative sign. So here we are taking the with positive sign, plus 3v1 upon 2 plus 4. Okay, and this is BV, second current in this branch current is BV minus BC upon 4, because here a dependent source with the current of 4i1. So this is the current of this branch, because this is an incoming current, so taking with negative sign, so minus 4i1 equal to 0. So this is my first equation, this is my second equation. But to solve the problem, we have required two equations, because we have the variable as I1 and B1. We cannot apply the KCL at this C because it is making the supernode. We cannot apply the D because it is making the supernode. So as we have say that there is the problem, there will always a solution. So dependent source create the variable, it will give you the solution. So see, the voltage of this source, dependent source B1, dependent voltage source depend upon the voltage of this source. So this is give you a one equation. So this voltage B1 is equal to the current into the resistance. So the value of B1 become equal to the resistance 2, and current in this branch is BA minus 6 upon 4 plus 2. So this is my third equation. Now fourth equation is because this source, see, this is a dependent current source, and current is depending upon this current of this branch current source. So this I1 current become equal to BA minus 3v1, because we are getting the positive sign. So this is BA minus 3v1 and minus BV, subtract this potential minus BV and divided by 4 plus 2. So now we have four unknown variable BA, BV, I1 and B1, and we have the four equation. So after solving this equation, we know the potential node potential of every node, or we can calculate the current or voltage of every branch or a register. Okay, now that is the question. Now move next. So in next lecture, for next is tutorial sheet. Now we are giving you some question. Okay, so just try to solve this problem. These are the basic concept. It will help you to make the concept to solve a problem. Okay, now first question. In the first question, we are giving a current source. This is my a current waveform. Okay, IT, and suppose this current is applied across an inductor. Okay, this is an inductor, and we are applying this current IT across the inductor. And question is saying find the value of BT or waveform across the BT. So voltage across the inductor is L di by dt, as we had discussed in the first lecture. So just differentiate this equation. So you can solve by two methods. Just try to find the mathematical equation of this waveform and differentiate this equation with respect to time. Multiplied with 2 millihenry, you will get the equation of the voltage, and from that equation you draw the waveform of the voltage source. Or when you the differentiation of this equation or direct differentiation, just try to find the slope of this equation, that is something positive and this is something negative. So the differentiation of this equation is equal to the slope of this equation, this waveform, and multiply that with the 2 millihenry, you will get the waveform. Okay, so this is the first question. Try to solve it. In second question, we have given a problem having some dependent and dependent source. Okay, just try to calculate the value of P1 and I1. Okay, and last lecture is an important. Last question is important question. In this question, we have considered some independent source and dependent source. So see here, this 2V, V1 is making V1 is making the super node, and this is also the dependent source. This 2I1 is making a super node. So just try to find the value of V1 and the current in this 4 ohm resistance. Okay, so solve the problem using nodal mesh or any current division method and find the value of V1 and I1 as given. Okay. So in next lecture we will discuss as the problem given here, and the mesh analysis. Although we have done mesh analysis from the 10th class onward, but in next lecture, what is mesh analysis and concept of super mesh analysis, we will take one more lecture to solve the basic fundamental of uh, uh, finding the current, that is mesh analysis and super mesh analysis, and a sheet of numerical example. It will help you to again make the concept. Okay, thank you.